This is section 5.2, the law of cosines. Let's look at the slide. These are the cases that we saw in section 5.1, and on those three cases we applied the law of sines. On this section 5.2, called the law of cosines, these are the two cases in which we are going to be applying the law of cosines. Let's go to the next slide. On this slide, we get to see the formula for the law of cosines. Notice that you have a triangle with sides A, B, C, and angles alpha, beta, and gamma. And notice that opposite to the angles, alpha you have little a, gamma you have little c, beta you have little b. Now let's look at the formula. You should be able to see a pattern when it comes to the formula for all three formulas. And in class I can clarify this a little bit more if you don't see the patterns, but they should be pretty obvious. This is the standard form of the law of cosines. Let's look at the alternative form. How do we get these new formulas, which is basically an extension of what you see on the left hand side? If you were to consider this first equation here, this first formula, and you solve for cosine of alpha, this is what you get. In the same manner, if you were to solve for cosine of beta, this is what you get, and so forth. We're going to be using these formulas whenever we're looking for a side, and we're going to be using these formulas whenever we're looking for an angle. Let's go to the next slide. So here's number one. It says solve each triangle round to the nearest tenth. So as you if you read the problem, notice that we have just three lowercase letters, which means that we have sides, and we need to find all the angles. So we're going to be using the alternative form of the law of cosines, namely to find angle A. This is the formula that I'm going to use. And notice all I'm going to do is I'm going to plug in the sides into the formula, and once I do that, it should be pretty straightforward. This is what I get, and then at this point pull out the calculator. Just go ahead and simplify that, plug that into the calc, and you're going to end up with a decimal pretty close to this. And I have cosine of angle A equals this decimal here, this approximation. Since I'm looking for an angle, this is where I have to use my inverse function to find the angle. I punch that into the calculator, make sure that I'm in degrees and in the degree mode, and this is what I get once I round to the nearest tenth, 20.7. Now to find to find angle C, I'm basically going to use this formula. Again, the alternative form for now cosine of C. So this is going to help you find angle C. Plug in the information into the right hand side here. I get the following. This is the decimal that I get once I punch it in. Notice that I'm trying to be as accurate as possible, so I'm using 4 decimal places. And then at this point, since I'm looking for angle C, I use the inverse functions for cosine inverse of that decimal, and I end up with 32.1 degrees once I round. And the only part that I'm missing in this triangle is the other angle B, and I'm going to be able to find that using the following: 180 minus the difference of this, 180 minus the sum of these two angles, and I end up with 127.2. And to solve the problem, to make what I want you to do to make sure that I'm not looking around for the answers through the entire paper, just go ahead and box them for me, and this is the answer to number 1. Let's go to number 2. So this one basically the same directions. Now the given information changes, and notice that I have little a, little c, capital B. What I'm going to do first, I am actually going to find little b, and to do that I am going to use this the regular form of the regular formula for the law of cosines. So from here I am going to substitute the a, the c, and the angle into the formula that you see there. This is what I get. I'm going to punch this into the calculator, and it's going to give me a decimal. I want to be accurate, so I'm probably putting too many decimals, but anyway. This is what I get, and then at this point, this is b squared, and which is approximately equal to this. I don't want b squared, I want b. So what I'm going to do is I'm going to take the square root of both sides, and this is going to give me the following b, 10.53. Once I know my b, I'm going to go and find another angle. And at this point, I could apply the law of sines, but I'm not going to. And in class, I'll clarify why I am doing that here. So once I apply the law of cosines, I'm going to find angle C. I plug in the information. This is what I get. At this point, I punch this into the calculator. I end up with the following. Since I'm looking for an angle, I use the inverse function for cosine, and it gives me 37.6. The only part that I'm missing is capital letter A, the angle. So I do the following. You should be able to see why that is. And I have my angle A. I finalize this problem by writing all the solutions that I found, and I box them. Let's go to number 3. So here's number 3. Same directions, different given information. Notice in this case I'm giving a side and 2 angles. In this problem, I won't be able to start out with the law of cosines. I am forced to use the law of sines. And once I do that, I should be able to find little a. So this is the ratio that I get. Proportion. So at this point, to solve for little a, I'm going to multiply both sides by sine of 20. And this is what I get. And I get approximately 6.5. Now I'm going to find little c using the law of sines. And I get the following. If I multiply both sides by sine of 120, this is what I get. The only part that I'm missing in this problem is basically an angle, which is beta. The way that I find beta is using the 180 minus the sum of the 2 angles that were given, and I get 40. And at the end, give all the information and just box it, all the information that I found, and I box it. Let's go to the next slide. So looks very similar to number 1, but this one I am going to do in class. Number 5. This is going to be a word problem, and this one, just like number 4, I'll be doing in class. Let's go to number 6. So here's number 6. You can go ahead and read the problem, and you're going to notice that the information in this problem corresponds to this picture. And what you need to do in this problem is you need to find this distance, the length of this guide wire, which I'm going to call W. So this is kind of small. I'm going to work with this picture instead. Is to have the same information. This is my guide wire here, and I'm going to call this W. From here, I'm going to focus on this oblique triangle here, and what I want to do is I want to find this angle that is here by you looking at this horizontal line, and I drew this horizontal line, so these two lines are parallel, and this transversal, you should be able to see that this is actually 28 degrees because of alternating triangles. In addition to that, this is a horizontal, this is vertical, which makes that this is 90 degrees. So if I want to find the degree measurement of this angle here, is going to be 118 degrees by simply adding the 2. Now that I have this, I should be able to apply the law of cosines to find W, and this is what I get. W squared 10 squared plus 6 squared, and so forth. From here, my goal is to solve for W. So what I want to do is take the square root of both sides. And this is what I get. I punch this into the calculator, take the square root, and I get 13.9 feet. And then just to finish the problem, just write the following sentence. The length of the guy wire is 13.9 feet. And this concludes the video.